Hi everyone, hi AP Chemistry class. This is the first lesson for the spring of 2019 for Advanced Placement Chemistry. I'm Mr. Mellinger, the teacher, and this will be a quick lesson. What I'd like you to do is take some notes on this in your notebook, and what I will usually do is check those and just spot check those to be sure that those have been done, that this homework has been done. So let's get started. Slide one, everything in the universe can be divided into two things. Matter, which is things with substance. It basically technically has mass and volume. It has to have some weight to it and it has to take up some space. That's matter. Also, there's energy. These are the only two things in the universe. Energy is what causes matter to move or change. So you can either throw an object or you could chemically change it in some way, and that takes energy as well. That's the kind of energy. The second type is the type of energy we're interested in chemistry. So physics is interested in different forms of energy. That could be electrical energy, wave energy, light waves, sound wave energy. It could be mechanical energy, the object of something moving, throwing a ball, heat energy, and we deal a lot with heat energy in chemistry. Somewhat with light energy, although not that much. But different forms of energy generally are the subject, the domain of physics. Chemistry is interested in matter and what things are made of. Okay, so this is so simple and so fundamental, yet you'll find that almost everything we do in chemistry revolves around this concept. Electrical force, and really electromagnetic force, but mainly electrical. The electromagnetic force is one of the four forces of nature, and just as gravity, it is a force of nature. The key point to remember about electrical force is this: that positive attracts negative, negative attracts positive. Positive repels other positives, and negative repel other negatives. Okay, so an element is pure matter that can't be subdivided into any simpler substances. Amazingly, there's only 90 naturally occurring elements in the entire universe. That's all there ever has been or ever will be. These elements, plus about another 20 that were created by scientists in the labs. All matter in the universe is made of these 90 elements. And just as there's 26 letters in the English language that can be arranged to make millions of words, the 90 elements can be arranged and combined to make millions of different substances called compounds. A compound is a substance containing two or more elements. The science of chemistry is really the study of which elements combine and why they combine, and the properties of their properties when they do combine. Okay, so the smallest piece of any element is called an atom. If you cut an atom of gold or iron in half, you will no longer have gold or iron. You'll just have some random protons, neutrons, and electrons. And those are the three things that an atom consists of. It consists of protons, which are positive charges, electrons are negative charges. Now, what's the real meaning of positive, negative? It just means that they're opposite of each other. They're equal and opposite. Although protons are much larger than electrons, they have the same electrical charge on them. So they're equal and opposite electrical charges. A third particle called a neutron has no charge. And those are the three particles that make up an atom. So here's a diagram of the simplest type of atom. It's called the Bohr model. It shows a nucleus and then perfectly circular orbitals going around it. Now, electrons don't really travel around in these circular orbitals, but it serves as a good enough model for us for many of the explanations we need to do in chemistry. So in the Bohr model, the atom proposed by Niels Bohr in 1913, simple circular orbitals indicate energy levels where electrons travel. So in this case of a helium atom, it simply has one orbital, but larger atoms of larger elements have more orbitals, and we'll learn that in the next day or so. So orbitals are spaces where electrons move around the nucleus. So those two blue electrons are really moving around and around and around the nucleus. The nucleus is the center of an atom. Unlike a cell nucleus that you might have learned about in biology, it doesn't have a pouch surrounding it or anything. It's simply the location where the protons and neutrons are located. The protons and the neutrons are held into the nucleus by the strong nuclear force, so they're not blown apart. The protons don't repel each other and push each other away, and they reside in the nucleus. The electrons negatively charged magnets that circle the nucleus. An important term to get to know is valence. The word valence means outer. So the valence orbital is the outer orbital of an atom. Because helium has only one orbital, this is the valence orbital. It's the valence electrons that form chemical bonds, and that's why the valence orbital and the valence electrons are so important. Okay, in its natural state, atoms have the same number of protons, positive charges, as electrons, negative charges. These atoms are said to be electrically neutral, so be familiar with that term. Electrically neutral means it doesn't have a net positive or net negative charge, same number of positives, same number of negatives. It's going to be electrically neutral. So when you look at your periodic table, you'll notice in a basic periodic table, there's 4 items. There's a number at the top, then there's a letter, and then there's the name of the element, and then there's a number at the bottom. So let's take these one by one. The number at the top is called the atomic number. This is the number of protons that an element has. It is also the number of electrons that that element has if it's electrically neutral. So in the case of hydrogen, it has 1 proton and it has 1 electron. There's a key point. The number of protons is what determines an element's identity. For example, hydrogen must have 1 proton. Lithium, which is Li on your periodic table, must have 3 protons, and so on. Hydrogen can have a different number of neutrons. Different hydrogen atoms can have different numbers of neutrons, different numbers of electrons, and still be hydrogen. But if it's going to be hydrogen, it has to have exactly 1 proton. If it's going to be lithium, it must have exactly 3 protons. And again, this is indicated by that number in the upper left-hand corner of each element on the periodic table. The atomic symbol is simply the abbreviation. You have to get to know these because you're going to use these in chemical formulas. So learn these abbreviations, and you will fairly quickly just by working with them enough. You really don't have to sit down and memorize them. The common ones will become known to you very quickly. Okay, third is the name. Most periodic tables will include this, some don't, but it's the actual name of the element. And finally, down at the bottom, the number is the atomic mass. This is the average mass or weight of the element. The reason that is a decimal number is because it is an average. Some hydrogen atoms might have an atomic mass of 1. In fact, most do. A few might have an atomic mass of 2, meaning that they have an extra neutron. We'll talk about that in a second. If you took the average of a large number of hydrogen atoms, you'd find that on average they have a mass of 1.01. So it's the average mass of a group of hydrogen atoms. Okay, so let's talk about atomic mass. What is it? Well, mass is basically how much matter something has. It's similar to weight. Not technically, their weight and mass are different, but we can think of it as the same thing. It's how much matter, how much substance, how much weight something has. So atomic mass is measured in atomic mass units. An atomic mass unit is formally defined as 1/12 of the mass of a carbon atom. Now, a carbon atom has a total of 12 protons and neutrons. So if you take 1/12 of a carbon atom, you're going to have an average mass that's of just about exactly the mass of 1 proton or 1 neutron. 1 proton, neutron, for our purposes in this class, have the same mass. There's technically a little difference, but for our purposes, we treat them as though they have the same mass. So since carbon has a total of 12 protons and neutrons, 1/12 of the mass of the carbon atom is the mass of about 1 proton or neutron. So we can kind of simplify this for our practical everyday purposes. We can think of the atomic mass as a unit, as the mass, an atomic mass unit as the mass of a single proton or a single neutron. We think of them as having the same mass, as weighing the same, and that mass is called 1 atomic mass unit. Okay, so we can think of an atomic mass unit as the mass of a single proton or single neutron. Now, since the atomic mass of each proton and neutron is 1, an element's atomic mass number tells us how many total protons and neutrons one atom has. Think about that for a second. If carbon has 6 protons and 6 neutrons, that's a total of 12 total protons and neutrons. That means it has an atomic mass of 12 because each of those protons and each of those neutrons has an atomic mass of 1. Another example, oxygen. Oxygen has 8 protons and 8 neutrons. That's a total of 16 protons and neutrons. And therefore, oxygen has an atomic mass of 16. 8 plus 8, 16. So the atomic mass tells you both the mass of the atom. It also tells you how many protons and neutrons it has. Okay, electrically neutral means that an atom has the same number of protons, positive charges, as electrons, negative charges. We talked about this earlier. The same number of positive and negative charges means that the atom is balanced electrically. We use the term electrically neutral to indicate that the atom has no net electrical charge. Okay, in our next lesson, at this point we're going to stop. In our next lesson, we're going to learn how to diagram an atom based on its position in the periodic table, its atomic number, and its atomic mass. And we'll take that up in class tomorrow. Okay, so this is the end. Just take some basic notes on this video, and again, I'll check those periodically. Part of what I'd like you to learn is the skill of note taking. So rather than have you fill out worksheets, I'm going to have you actually just take your own notes. All right, so you have a great day. We'll see you in class tomorrow. Bye-bye.